Hi kids, I'm Peter Paluski at NASA Ames Research Center. I study light in the Earth's atmosphere. What can I do for you today?
We're trying to figure out a problem, and we need to know why skies are blue during the day.
Good question. Let me first talk to you about the sun. It's a white light, which means that it's really a mixture of all colors of the spectrum, from blue to red.
If the sunlight is white, then why is the sky blue?
We learned about reflection at the Jefferson Lab. Could the sky be blue because it's reflecting blue off the ocean?
No, that's a common misconception. The Earth has an atmosphere, which is made up of molecules such as oxygen and nitrogen. It's also made up of tiny little microscopic particles. And these tiny little microscopic particles in the atmosphere are called aerosols.
I don't see anything in the air.
Well, let me ask you first, what do you know about light?
We learned at the Boston Museum of Science that light is a wave and that it is made up of photons.
Occasionally, the photons will actually bounce off of the molecules and particles and go off into different directions. That's something that we call scattering. Let me show you an experiment I have set up here. This fancy instrument is something we call a sun simulator, but really it's just a lamp which sort of mimics the output of the sun. First of all, you can see the beaker here has very little light scattering out of the sides of it. Now watch what happens when I add some milk to the beaker. What does the milk represent?
The molecules and particles in the atmosphere.
Now we've got plenty of light scattered out the sides, and notice it's very bluish. When we look at the sun beam that's been transmitted through the beaker, however, that's become reddened. That's because the blue light's been removed from the beam and it's scattered out the sides.
Just like the sky looks blue, but I don't understand.
Remember we said that sunlight is a mixture of all colors. Now the blue photons will actually scatter off of the particles much more frequently than the red ones. That means that we get blue light scattered out and the red light gets transmitted through.
So why do we see red skies at night and in the morning?
Well, when the sun's near the horizon, the sun beam is traveling through a very, very thick portion of the atmosphere. That's also where most of the particles are concentrated because gravity keeps the particles near the ground.
That makes sense.
Any event that puts more particles near the horizon can make the sunset and sunrise even more red than it is usually. Now, one of those events is a pollution event. I'm not an expert in pollution, but I happen to know one. His name is Mark, and he works at the Langley Research Center. So why don't we give him a call?
This is so cool.
Wow, looks like we found the right place.
Hello, Mr. Vaughn.
Hey guys.
Well, we need to know more about what causes air pollution.
Mostly when we think about air pollution, we think about the things that human beings put into the air. We think about the emissions from factory smokestacks. They're thinking about the exhaust from automobiles. But when we actually get down to measuring the aerosol content of the air, we find out that human beings account for only about 10% of it. The other 90% comes from Mother Nature herself.
Mother Nature? But I always thought that nature was clean and natural.
Think about a volcano going off. It's not just lava that comes out of that thing. It also spits blistering hot gases way, way, way up. And those gases react with water vapor to form little tiny sulfuric acid droplets that can hang around in the stratosphere for years. Or think about big dust storms coming across the desert.
How do you know how much dirt is in the air?
Matthew, you'd be a cloud with the squirt bottle. PJ, you are going to be a LiDAR with the laser, and I'm going to stand here, my flower, and be a dust storm.
Wow, they look like sparkles.
You bet they do. We use a very similar technique when we measure real aerosols in the atmosphere. Only then we use a machine called a LiDAR. Come on, I've got one right over here I can show you.
Wow, this is a big machine. What does it do?
What we do is fire pulses of laser light out of the laser and right to this turning mirror here. From there, they shoot straight up into the atmosphere. We shoot that beam out, and just like we saw the sparkles off of aerosols in our little experiment, we use our telescope to look at the sparkles off of real aerosols in the atmosphere.
Could the aerosols from pollution cause the sky to turn red during sunrises and sunsets?
Sure they can. The circumstances are right.
We learned from Dr. Paluski that aerosols scatter more blue photons and leave the red ones for us to see.
Oh, absolutely. If you increase the number of small particles up there, they will scatter away more blue light, and you will see more red.
Thank you, we've learned a lot.
Good.
Thanks.
Good luck on your project.
Bye.
Bye.